Good morning, students. Since last few sessions, we are discussing about different techniques for managing the main memory of a computer. Main memory is also known as primary memory. In our last session, we discussed about a one memory management technique called partition memory management. As the name indicates, in a partition memory management, the entire physical memory is divided into number of partitions, and each partition is allocated to a different job. Since more than one job can be there in the physical memory simultaneously, this technique supports multi-programming. And when compared to single contiguous memory management techniques, which supports only single user, so only one job can be there in the memory at a time. Whereas in the case of partition memory management, more than one job can be there in the memory simultaneously. We also discussed about different techniques for allocating partition to different jobs. So whenever a partition has to be allocated to a particular job, there are two ways for allocating the partitions to the job. The first one is first fit, and the second one is best fit. In case of first fit technique, the free partition table is first kept sorted by the location. So whenever a partition has to be allocated to a job, it keeps on searching from the beginning of the table, and whenever a partition is found whose size is bigger than the job size means, then that partition is only allocated. The problem in the case of first fit technique is the partition that was allocated to a particular job may not be the best partition. It may not be results in best utilization of the memory. Sometimes you allocate a partition for a particular job, and the job may not utilize all the space in that particular job partition means most of the time the memory is wasted in the case of first fit technique. In the case of best fit technique, what happens is the free area table is first kept sorted by the size. The first partition is of smaller size, then the next comes the higher bigger one, then comes the bigger one, and so on, and the last area or last entry in the free area table will be nothing but the partition of the biggest size. So size will be in the increasing order of the size. So there in the case of best fit technique, whenever a partition is to be allocated to a job, then it allocates the partition which results in least wastage of the memory. So the best partition which is suitable for the particular job is allocated. We discussed about the merits and demerits of each of these two partition allocation techniques. In today's class, we'll be discussing about one important memory management technique called paging memory management technique. The main idea of designing paged memory management technique is to eliminate the drawbacks or the demerits of partition memory management. We already know what are the major drawbacks of a partition memory management. One important drawbacks of a partition memory management technique is fragmentation. Fragmentation is nothing but in every partition, some area of the partition is utilized by the job and some area of the memory remains unused. So that free area is left in each and every partition, but the free area which is left in each and every partition is not continuous. In every partition, some space is wasted. So that space that is wasted, we call it as a hole also. So there will be several holes in the memory in each and every partition. So if it is possible to combine all these holes into one single contiguous allocation means that will be useful. Whereas in the case of partition memory management technique, the free area will not be continuous. The free area will be there in each and every partition, but it is not continuous. To avoid this technique, to avoid this major drawback, there are two techniques. One is called as relocatable partition memory management, and the other one is paged memory management technique. In the case of relocatable partition memory management, what happens is first partition is taken, some portion of the partition is occupied by the job, and the next part is wasted. Then comes the second job. Then what we'll do is all the jobs will be shifted on the top. Then naturally all the free area will form at the bottom. So there in the case, this technique of shifting all the occupied areas into one place and naturally forming the free areas into another area, this technique we call it as a compaction. So using compaction technique, the fragmentation problem is avoided in case of relocatable partition memory management technique. We discussed about what are the advantages and disadvantages of compaction. Compaction, the advantage is theoretically very simple. It eliminates fragmentation, but it leads to some other problem also. Because whenever you shift a job from one location to another location, some instruction in the program may not work after you shift the job to the new area. So shifting the job to the new area and still see that when the job work fine. The technique we call it the relocation. So whenever you relocate a job, sometimes the address sensitive instruction may not work. So this is the biggest drawback of compaction problem. So the another technique which eliminates fragmentation without doing compaction is paged memory management technique. So in today's class, we'll be learning about what do you mean by paged memory management technique, how fragmentation is avoided in case of paged memory management technique, what are the advantages and disadvantages of paged memory management technique. So at the end of the today's session, you will be in a position to understand how the fragmentation problem is eliminated in case of paged memory management technique. We are also learning about what do you mean by a page and how paging is done and its merits and demerits. Fragmentation, as I told earlier, is the biggest drawback of partition memory management technique. The two ways of avoiding the fragmentation or eliminating the fragmentation is one is through relocatable partition memory management technique. The other one is paged memory management technique. In the case of relocatable partition memory management technique, as I told earlier, the fragmentation is avoided through a technique called compaction. But compaction has its own advantages and disadvantages. We already studied the advantages of compaction and also the disadvantages of compaction in the relocatable partition memory management technique in our previous session. And another problem is the job address must be continuous. That means in every partition we are getting some free area. In that case, it is not possible to divide the jobs itself into pieces and load each and every piece in different partition. So that is not possible. Whenever you want to allocate a job, in that case, the job address must be continuous. So this is the major drawback of relocatable partition memory management. But another way of avoiding the fragmentation problem is through a technique called paged memory management technique. This is how compaction is done. The first area is operating system, then comes the process one, then some whole. So that is these two areas together we call it as a partition one. In partition one, some portion of the partition is occupied by process one and some portion of the memory remains unused. Then comes process three again and some memory hole. So the first partition is in the first partition we have process one, the second partition we have process three, and the last partition we have process five. So we can see that color also. The process are indicated with white color and the memory hole is denoted with some light blue color. So in the case of this is the left hand side of the table indicate the fragmentation problem and the right hand side indicate the compaction. So what you do is immediately shift the process 3 immediately after process 1, then shift the process 5 immediately after process 3. Now what happens is process 1, process 3 and process 5 will be continuous. Then at the bottom, we have completely unused space means you will get a huge chunk of free area. So whenever a new request comes, whenever new jobs come for which memory has to be allocated means you can allocate it at the bottom. So this is the technique of compaction. So in every partition, some area remains unused. So in that case, what you do is you shift the job which comes, you shift the process which comes after that to that position, then keep on shifting the process to one place, then actually free area will form at the end of the memory. But in case of paging technique, the technique is very, very simple. The physical memory or the main memory is first divided into number of pieces. Each piece we call it a block. And your job is also divided into pieces of same size. So every piece of the memory that is divided, we call it as a block. And every piece of the job which has the same size of the block size, we call it as a page. So that means in one side we have memory, in one side we have the job. So physical memory first you break up into pieces, each piece we call it as a block. Like that, a job is also divided into pieces of same size. Each piece of the job or the process, we call it as a page. For example, every memory, every block size is 1000 bytes. Suppose the job is of size 2600 byte means that is also divided into three pieces. First piece 1000 size, second piece is also 1000, and the last piece is also 1000 only. But the last piece, what happens is only 600 is used, the remaining 400 is wasted. That we'll see later. So then by suitable hardware mapping mechanism, what we do is a particular page is loaded into particular block. So in the memory, we have blocks. In the program, we have pages. You take first page, keep it in some block. Take a second page, you keep it in some block. So there what happens is the pages need not be continuous. The memory is continuous, but the pages need not be continuous. So this is the restriction in case of partition memory management. In the case of partition memory management technique, what happens is job also must be continuous. So you cannot have the one piece of the job in some area of the memory and another piece of the job in some other area of the memory. So this is possible in case of paging technique. So after dividing the physical memory into blocks and after dividing the jobs into pages, what you do is using some suitable hardware mapping technique. Any page, you can keep it in any block. So the pages need not be continuous. So it is the responsibility of the processor to retrieve the pages in an order. So the user programs are unaffected by the mapping because it has no visible effect on the address space. So even if you keep different pages in different places of the memory, it does not have any problem for the user because whenever a job has to be executed, the processor fetches the first page by looking at the particular block, then fetches the second page by looking at the again in the memory. So then it will bring all the pages together. So that is not visible to the user. But physically, the job is not continuous. This is how it happens. For example, first we have this is a diagram which illustrates paging technique. First block indicates job 1, which is divided into two pages. So job 1 P1, job 1 P2. So now the first job occupies requires two blocks because it has two pages. Second job is divided into how many pages? Three pages. Job 2 P1, job 2 P2, job 2 P3. Like that. The third job has only one page. So the left hand side box indicates the address space. The first box indicates the address space of job 1. Next indicates the address space of job 2. And the last one indicates the address space of job 3. Now, in the right hand side, extreme right, you can see the memory is also divided into number of blocks. So there what happens is assume that the first part of the memory is the operating system. Operating system also occupies some block. Let us assume that the operating system has occupied two blocks. So block 1 and block 2 is occupied by the operating system. Then the remaining block 3, 4, 5, 6, 7, 8, 9, 10. Remaining blocks are available for the user. So then we will take the first job. First job, page 1. Second job, the first job, page 2. Now, the first page of the first job is loaded in the sixth block. You can see the mapping. Next, the second page of the first job is loaded in the block 7. Okay, then you take the second job. It has how many pages? 3 pages. 1, 2, 3. First page I'm keeping in the memory block 3. Second page I'm keeping in the memory block 5. And the third page I'm keeping in the memory block 8. Whereas the last job requires only one block that you keep it in the memory block number 6. Now we can observe here the blocks which are allocated to a particular job need not be continuous. That you can see it from the example, especially in the case of job 2. The first page is in third block. Second page is not in the fourth block. Second page is in which block? Fifth block. Whereas third page again is in 8th block. So the different pages are kept it in different blocks of the memory. So now what happens is you need not do compaction. Without doing compaction, we can avoid the fragmentation. Wherever space is there, you can load the page there. Let us see how the 4 memory management functions are handled in case of paging memory management technique. The first one is keeping track of status. So this is done by means of 2 different types of table. One is page map table. Other one is memory block table. Here, the middle boxes indicating the 1, 6, 2, 7, 1, 2, 3, 3, 5. That page is considered as a page map table. In the case of page memory management technique, we will use another table called memory block table. Page map table will be there for one page map table will be there for each job. Whereas for the entire system, we have only one memory block table. So the memory block table indicates whether the block is free or occupied. For example, in this case, when you consider the memory block table, 1, 2 is occupied by the operating system, third is occupied by job 2, fourth is free, fifth one is occupied by job 2, sixth one is occupied by job 1, seventh one is occupied by job 1, eighth is occupied by job 2, ninth is occupied by job 3. Whereas second 1, 2, fourth block and the 10th blocks are free. So the memory block table indicates which are all the different block number, and it also indicates the status of the block, whether the block is a free or allocated. In this case, block number 3 and 10 are free. All the remaining blocks are in allocated status. Whereas there is separate page map table for every job. Determining who gets the memory, how, when, all this. So allocation policy. This is done by a job scheduler in case of paged memory management technique. And allocation. So whenever a job has to be, whenever memory has to be allocated, then what the operating system will do it will take the job, divide the job into number of pieces called pages, then identify the blocks which are in the free status by looking at the memory block table. And you can suppose the job requires 2 blocks and the 2 blocks are free at in third in the location 4 and 10 means then the first page is loaded in the 4th block and the second page is loaded in the 10th block. So when the moment what happens is you have 2 different blocks free. First block free is 4th block and the last block which is free is 10th block, but they are not continuous. So it leads to fragmentation only. So no problem. No need to shift the occupied job into one place. Let the memory there only. What you do is you divide the program into 2 pages. First page you can keep it in the 4th block and the second page you can keep it in the 10th block. So in that case what happens is without shifting the allocated area into one area, we can avoid the fragmentation problem. So paging is one very, very popular memory management technique which avoids the fragmentation problem of partition memory management technique without doing compaction. Without doing compaction, we are avoiding the fragmentation problem. Deallocation. After the job execution is over, that particular job is removed from the memory and the status of that block is once again returned back to free status. So whenever deallocation is done, we have to make appropriate changes in the memory block table. Let us see some of the advantages and disadvantages of paged memory management technique. First one is no fragmentation problem. So fragmentation problem is a problem in case of partition memory management. So that is not there in case of paging technique. And that also here also we can load more than one job in the memory simultaneously. Paging technique also supports multi-programming, that too no fragmentation problem. And it results in better utilization of both memory and processor, because since more than one job is there in the memory, processor will get maximum works to do. So you are utilizing the processor to the best possible way. That is at the same time, we are not keeping only one job. We can keep several jobs in the main memory means multi-programming is there means. So depending on how many jobs are there in the memory, that tells the degree of multi-programming. If 2 jobs are there in the memory means degree is 2. Instead of 2 jobs, we are keeping 3 jobs means the multi-programming degree is 3. So since more than one job is there in the memory means you're utilizing the memory also to the best possible way, and processor utilization is also good. So we have better utilization of both memory and processor. High degree of multi-programming, because degree of multi-programming is decided by the number of job that is loaded into the memory simultaneously. The important advantage of paged memory management technique is the compaction overhead. Where we can see the compaction overhead, the compaction is the biggest drawback in case of relocatable partition memory management. So in the case of paging technique, without doing compaction, we are avoiding the fragmentation problem. Is that time you can save it. So no compaction overhead. And here also the one other advantage of paging technique is the pages need not be continuous. For example, in the previous example, the block number 4 and the block number 10 are free. So whenever a new job comes that requires 2 pages, that has 2 pages then those 2 pages need not be continuous. First page you keep it in 4th block and the second page you can keep it in the 10th block So even though the blocks are not continuous, we are dividing the program itself into pieces. Each piece I am loading in different blocks. So the job address space need not be continuous. So there is no, suppose the job requires 2 blocks, then there is no rule that the 2 blocks must be free continuously. 1 block may be free in the 4th place, 4th block may be free, and the 10th block may be free. You can allocate it. Sometimes 3rd block and the 6th blocks are free. No problem. First page you can keep it in the 3rd block, and the second page you can keep it in the 6th block. But a paged memory management technique also suffer from certain drawbacks. One is it requires more number of table. We require page map table, we require memory block table, etc. So the addressing and that too, after dividing the program into pages, after dividing the memory into block, we need to do some mapping to load a particular page into particular block. So that mapping hardware increase the cost of the computer. So in any computer where if you want to implement paging memory management technique, the cost is more. And at the same time, it slows down the processor because first you have to do the mapping. After that only the execution start. And here I told earlier, this technique requires more table and hence it increase the cost, and also the overhead is also involved in. So whenever a job allocation is done, means we need to make changes in many table. We need to make changes in page map table. We need to make changes in memory block table, etc. Similarly, after allocation, after execution is over, during deallocation also, we need to update these table. So that itself takes little time. And memory will contain certain information. Sometimes the information is not used at all, so rarely used. And here also, the job address space must be less than or equal to the available physical memory. Suppose there are 3 blocks free, and whenever a new jobs come which require and we require 4 blocks, means if the number of free blocks available are 3 and the job need 4 blocks, means you cannot execute such a job. Suppose the number of free blocks are 3 and the number of pages in the new job is 3, means then such program only we can execute. So that means the address size of the user address space must be always less than or equal to available physical memory. But another small minor problem in the case of paged memory management technique is internal fragmentation. What do you mean by internal fragmentation? Suppose every block is of size 1000 bytes. In that case, page is also how much? 1000 bytes only. Suppose there is a page, there is a program of 3200 bytes. Then how many blocks it requires? It requires 4 blocks, because you cannot have the different pages of different sizes. So if every page of equal size, means first page is also 1000, second page is also 1000, third page is also 1000, last page is also 1000. Then actually it requires how many blocks? 4 blocks. First page 1 block, second page 1 block, third page 1 block, last page 1 block. So suppose the job size is 3200, means first 3 pages occupy 3 blocks, no problem. Whereas in the case of last page, it requires only 200 bytes. For that one also, we are allocating the memory of 1 complete block, means that is 1000 bytes. So in that case, what happens in the last block, for the last page, requirement is only 200. Still, you are allocating a block of 1000 byte, means 800 bytes is wasted in one particular page. So such a wastage, we call it as internal fragmentation. So this is the flowchart for illustrating the paged memory management technique. Here also, first request to allocate a partition of size lambda k. Lambda k means suppose the job require 3200, means then it require 4 blocks. So in this case, lambda become 4, like that. Then f equal to 1 means the partition number is 1. Then you check whether f is the end of the free table, etc. So this is a very simple flowchart illustrating paging memory management technique. Based on today's class, some review questions, and one thing you should remember is paging is a very, very important and also a very popular memory management technique. So most of the time in the examination, you'll get some question related to paging memory management technique. Mention the different techniques for eliminating fragmentation problem. Discuss paged memory management technique in detail. Mention the merits and demerits of paged memory management technique. Write a note on different tables used in paging technique. Let us take some few simple multiple choice questions. Fragmentation problem is avoided through paging technique, relocatable partition technique, either A or B, none of these, because both A and B, we can avoid fragmentation problem, because fragmentation problem comes only in partition technique. So the correct answer is B. Sorry, correct answer is C, either A or B. Drawback of paging technique is external fragmentation, compaction overhead, internal fragmentation, job address space must be continuous. So first one, second one, and the last one are wrong. The correct answer is C. In paging technique, physical memory is divided into what? Physical memory is divided into block, whereas job address space is divided into pages. The correct answer is B. Oh, sorry, the correct answer is not segment. The correct answer is block. Correct answer is B. A small correction, you can make it. Dash is a solution to fragmentation problem, buffering, partition merge, memory merge, compaction. So we can, using compaction, we can avoid the fragmentation problem. The correct answer is D. Job address space is divided into segments, blocks, holes, page. So you should remember Job address is divided into pieces of same size called page. Physical memory is divided into pieces of same size as the page size. Each piece of the physical memory, we call it as a block. So the correct answer is D, pages. Mapping of pages into block is represented through page map table, memory block table, free status table, none of these. It's mapped. So which page of a particular job is in which block, you can come to know through by searching the page map table or PMT table. The correct answer is A. So students, in today's class, I explained the need for paging memory management technique. We require paging memory management technique to avoid the fragmentation problem, which is the biggest drawback in case of partition memory management technique. In our last class, we learned about one simple solution to avoid the fragmentation problem called compaction that we have adopted in relocatable partition memory management. But the compaction, the overhead time is more, and that too, it's some address sensitive instruction may not work when you do the compaction. Another solution for compaction, another solution for fragmentation without doing compaction is paging technique. Basically, in paging technique, memory is divided into pieces called block. Job address space divided into pieces called pages. Then using some suitable hardware mechanism, you map a particular pages into particular block. So pages need not be continuous. Wherever the blocks are free, you can allocate the pages there. Or we can map the pages to that particular free block. So in case of paging memory management technique, basically we require two blocks, two table called page map table and memory block table. And page map table is there for every job, one page map table is maintained. Whereas for the entire system, we maintain one memory block table. We studied the advantages and disadvantages of paging technique. Advantages are no fragmentation, no compaction overhead, supports multi-programming, better utilization of processor and memory. And the drawback is job address space is less than or equal to available memory. At the same time, it suffers from one another drawback called internal fragmentation. With this, I will conclude today's session. For any of your doubt, you can call me over that number or through mail. Thank you.